Hi, everyone. Thanks for joining us today to talk about optimizing customer experience using segmentation and 3 ways to optimize your infrastructure to implement data-driven targeting. There is a question queue. It's the one labeled Q&A. If you'd like to ask us questions, please drop those questions there. We want to minimize disruption throughout the session today, and we will get to your questions at the end. If we don't get to yours today during this session, we will follow up with you afterwards. So I'm Erica Fowler. I am Senior Product Marketing Manager for Molecula. I've spent the last 12 or so years in strategy and analytics across multiple industries and have a PhD in epidemiology, which is where I found my love of data and analytics. And I've done a lot of segmentation in my career, and I'm really excited about what we're going to share with you today. I'm here with my colleague, Matt Jaffe. He's Distinguished Engineer for Molecula. Jaffe, do you want to introduce yourself?
Yeah, Matt Jaffe. I've been with Molecula for the majority of my career now, since we spun out from another company, which we'll talk about a little bit later. But I have a background in both physics and computer science, and I'm really excited to talk to you all today about what we've been doing for the last 6 or so years.
All right, so Molecula closes the gap between data and decision, enabling organizations to unlock the power of real-time analytics and AI. By eliminating resource-intensive pre-aggregation, Molecula accelerates data-driven business innovation.
Yeah, so that's a lot of fancy words to say, hey, we've got kind of a novel database technology, that we think can really change the way that you do analytics, and that's really at the core of what we're doing.
Awesome. So what we're going to walk through today, we're going to do a review of segmentation, the basics, so that we're all on the same page, and then we're going to talk about how to optimize your architecture for customer experience using segmentation, and then we'll do a quick demo of our product, FeatureBase. And then finally, we'll wrap up with the Q&A and discussion. And again, if you have any questions, just drop them in the queue. We'll get to as many as we can today. And then if we don't get to you, we'll follow up after the session. So for segmentation, what is it and why is it important? So there are a lot of different definitions of segmentation, but I really like this one that I found from the Economic Times to describe it within the context of marketing. So according to this definition, segmentation is to divide the marketplace parts or segments, which are definable, accessible, actionable, and profitable, and that have growth potential. So all of these components are really critical to implementing a segmentation process with the biggest possible impact that you can have on your business. And we'll really briefly touch on a couple of these criteria. So first, they're definable. So the criteria used to identify those people that are eligible for the segment given some set of data, it has to be definable and something that you can actually measure. So without this, segmentation tends to rely on like a gut feeling, and there may be some bias, or you're looking at just a really narrow set of information, and you could have brought more stuff into the picture. Additionally, it has to be accessible. So the data needed to identify those segments must be, available for you to use. So if you can't get to the data is not accurate, or it's not something that's actually measurable, then it won't do you much good in terms of identifying those segments. And then it also has to be actionable. So just because you have data in hand doesn't necessarily mean that you can use it for what you want to use it for. So it may be unethical, or it might be illegal, or it might just simply go against a data use agreement that you have. So, you're potentially using data under a third-party agreement, but the person that you're using it with has a contract that says you can't let anyone else use this data for certain purposes. Marketing is typically one of those. And in the financial industry, things like gender or race, they can't be used to make like financing decisions. So just because you have the data in your hand doesn't mean it's actually actionable. And then next, I think there's a lot packed into this, but it needs to be profitable. So the process used to implement the segmentation should have a positive ROI. So it's important to not only measure those obvious costs, like the cost to design content or to implement some new technology solution. You also want to think about things on, each side of that process, like the engineering cost to keep it running, or if your program offers something like a coupon that you're wanting to get the redemption rate up on. When you increase that conversion rate for the coupon, so your coupon costs are going to go up, and there's different budgetary reasons why you'd want to know that. For example, like you might have to front your coupon budget at the beginning of a quarter as an estimate, and then if you get that estimate wrong, it might derail some of the other projects that you have going on in your organization. And then lastly, there needs to be growth potential in your market. So if you're already kind of saturated the growth potential in a segment, no amount of segmentation is gonna improve that. So I'll stop there. And Jaffe, I know that we've had some talks about this. So is there anything you want to add around these definitions?
Yeah, I won't say I had come across this definition before, working at companies that were doing a lot of segmentation stuff. But I think the thing that strikes me that kind of is a thread that runs through all these and really rings true is measurability. Whether you're talking about profitability or being able to define your segments or like understanding whether there is growth potential or not, you really have to be able to measure everything about this process, and measure the costs associated with it, and measure the outcomes that you're getting. That is really key to sort of having a successful strategy around customer experience generally, and doing segmentation particularly.
Yeah, definitely. And even if like I've had some experience where our end outcome, like we didn't have point of sale information, so it was really difficult to communicate to our leadership whether or not the program was working, or to really calculate an ROI, because it was this really fuzzy, like using different proxies. So the measurable aspect and making sure you can tie it back to some kind of outcome that your leadership has bought into, and is gonna like really understand, like, yeah, maybe I don't have point of sale, but this other proxy that we've aligned on is going to be what we're going to ground the results on, is really important. So even if like the exact thing you're trying to measure isn't available, having some sort of proxy that everyone is really comfortable with using could be another option if it's not that like thing that you really need isn't available.
Well, and what's really fun is you may not know ahead of time what you want to measure, and you may find out like, oh, after you went through this whole process, like, wow, we really need to add point of sale information back at the beginning, so that we can measure the right outcomes. And depending on how your architecture is set up, that could be easy or it could be really, really hard.
Definitely. Yeah, it's an iterative process, and sometimes that is one of the most difficult parts about it, is that you want to be able to iterate really quickly, and we'll get into some of that later when we're talking about more of the technical details. So again, kind of digging into segmentation, it used to be, or it still is in a lot of places, this isn't really like a then and a now comparison when we're talking about the history of segmentation. It's more of a continuum, and people can go back and forth on this continuum depending on what they're trying to accomplish. But in marketing, it used to be a quarterly or an annual event where you divided up customers into a handful of groups to send out varied communications, so that those communications were more relevant to that group. So for example, on the screen here, we have late adopters, early adopters, or innovators. And so you may have different messaging around your product, or different offer values that you might send them. Like a late adopter might need a much more hefty coupon to get them to convert, versus somebody that's like really willing to do things early on and in the product life cycle. But customer expectations are evolving, and we'll get into a little bit more of that in a second. But being one of a large group no longer really resonates with customers. They're expecting more of a one-on-one relationship from the companies that they're interacting with, and they expect tailored communications and a frictionless experience. So they want to be able to interact with your brand or your product in a way that doesn't intrude on their life. And so to be able to meet those expectations, you really have to understand who your customer is and be able to tease out the things that they want or don't want based on all of this data. And there are, so many advances in data technology techniques the volume of data that we're able to collect and process through. So segmentations become a much more granular endeavor. So you're really looking at that individual relationship or close to individual. And we're starting to offload work to machines. So it's not always just a human that's there, and we're having to scale these systems up. So I don't know, Jaffe, if you want to talk a little bit more about that.
Yeah, I mean, I think the offloading to machines point is really critical, because the more personalized and targeted and individualized you get in this process, the further to the right on this spectrum you get, the more effort you kind of have to put in per group or per person. And so, again, going back to profitability, you want to make sure that you're not putting in more than you're getting out, or it's just pointless. So moving to machines and moving to more efficient processes and software under the hood is what's going to allow you to move to the right on this spectrum and still stay in the green or in the red or in the black.
Definitely. So I know we're talking about segmentation in the context of customer experience today, but I just wanted to highlight that the underlying concept behind segmentation is called clustering, and it's really applicable across a variety of use cases that on the surface might not seem completely, may not seem related, but they really are, because you're sifting through large amounts of hierarchical data, identifying patterns that indicate a group of customers or pieces of equipment or high-risk lenders that are more or less likely to contribute to some outcome that you're looking at. So these things could be purchasing a product or engaging with content, or, like I mentioned, an equipment failure. So there are some other clustering use cases that are really similar underneath the surface, but today we're really going to focus on customer experience.
Yeah, absolutely. The underpinnings, the sort of technology behind this is very broad in its applications, but the OG use case is definitely the customer segmentation, customer experience, and that's what we really want to dive deep on right now.
All right. So optimizing customer experience. So one of the things that, we talked earlier about, the customer expectations, they're evolving, they're expecting this frictionless experience. We know that, 84% of customers say customer experience is just as important as the product that they're purchasing. And, a majority of them want that personalized experience. And also a third of customers, they, stop doing business with a brand that they love after just one bad customer experience. And we also know that most companies, about 80% of them, believe that customer experience is a really powerful competitive advantage. But we have found that 73% of brands can't provide a consistent experience across channels because they lack the necessary technology solutions. And this is coming from a 2021 survey from the MarTech Alliance.
Yeah, and I mean, that's totally believable, right? Like, who hasn't, filled out the forms for their doctor online and then filled them out in person, and then had the doctor ask the same set of questions when they actually get into the room. It's not just healthcare, but I think they are, one of the top offenders in this area.
Definitely. And I think even with healthcare, on the other side of that, we're talking about the patient as a customer, and then the experience that they have having to fill out these forms, multiple times. But on the other side of that, the physician, who is very highly trained in actually treating patients, is becoming more of an administrator, and physician burnout is a huge problem. So if you think of the HCP as another customer in this equation, their experience is also, it's not frictionless in any way. So there's multiple ways that, especially within the healthcare field, that this could be addressed, and really this friction could be reduced by really efficiently and intelligently using the data that you have available.
Yeah, customer experience, definitely not just for retail, not just for brands. It crosses a lot of different sectors.
Yeah, definitely. All right. So we've listed 3 keys to a relevant customer experience. So I'm going to turn it over to to the expert here.
Yeah, so I I like to get these kind of definitions right up front, because a lot of times people throw words around. When we talk about freshness, we're talking about the time from when a data point is generated until when it's available to your analytics. If you've got, a fancy application that allows you to look at your audiences and do segmentation, it's the time from when customer takes an action until you can see that action in your analytics. That's freshness. Latency, on the other hand, is the time it takes from when you run some kind of query in your fancy analytics front end, whatever that is, whether it's at the command line or you have some kind of UI on top of it. When you ask that thing a question, how long does it take to get an answer back? Is it milliseconds? Is it seconds? Is it minutes? Is it days? That's what we mean when we say latency. And then the third thing here is an interesting one. It's concurrency, which is how many people or entities can you have using your analytics simultaneously? And this becomes, if you're, a small shop or like a single company, a small company, this may not matter as much. But if you are a company that is providing services to other companies to, like Umble was, for example, concurrency is a really big deal. Like how many people can use this thing at the same time? It is how many concurrent queries can it handle?
So on this slide, you can see a general architecture that might be used to serve dynamic ads. And I want to call out that this is the type of architecture that we're generally able to help simplify and make more efficient. So this is kind of what it would look like before Molecula or FeatureBase were in the picture. So you would have your data sources coming in on the left-hand side that would kind of funnel into your data storage solution. And then you would pre-aggregate that data for model training, model validation, register your model. Then that would go back into your data storage system. You might then score your population there based on the model, send out your programmatic advertising, have those results come back and tied back to the customers that you had segmented, and then you might pre-ag that again so that you would be able to feed into your reporting and analytics. So this pre-ag, this red box here is kind of on the critical path in a lot of different places. This isn't just a one-way journey that you're doing. So Jaffe, do you want to maybe illustrate a little bit more about this pre-ag?
Yeah, it looks innocuous. Well, until we put the red box around it, then that kind of draws your eye. But it's really at the center of a lot of these flows, right? The machine learning flow, or you get data initially. You might serve some ads based on that data. You get performance data from the ad serving. You got to run that back in. The pre-aggregation is typically a trade-off between freshness and latency. So the amount of time the amount of pre-processing you do on your data is going to dictate how fresh it is when it becomes available for analytics. And more pre-processing typically means that you're able to do analytics faster. And another thing to call out is more pre-processing usually means less flexibility in those analytics. It means you can't necessarily do all the queries you wanted to do because you've aggregated the data. You've lost some fidelity. So it really is kind of a thorn in the side of a lot of these architectures, and definitely deserves to have a red box around it.
Yeah, and pre-aggregation, it's if you're not familiar with that term, I've heard it called a lot of different things: roll-up tables, summary tables, OLAP cubes. So they're really, really, really common, and they're almost so common that you don't really know that you can do without them, because it's just kind of how things have always gone. So and then one other thing to touch on here is it's not just that initial pre-aggregation occurrence that happens. You also have to typically monitor these things and keep them up to date. And they might break if something happens in the system. As Jaffe mentioned, they're not very flexible. So sometimes it's really hard to identify all the things downstream of a pre-aggregation that need to be monitored and sometimes fixed or whatever. So so this is an example architecture that you might see traditionally in serving programmatic ads and some of the inefficiencies there.
Yeah, I mean, remember we talked about point of sale data earlier. Like if you didn't have that and wanted to add it in, if you've got a whole bunch of stuff going on in that pre-ag workflow, a bunch of custom jobs or whatever, adding in a new field is not necessarily a trivial endeavor. You might have to change a lot of code in a lot of places, and then reprocess a lot of data to make that happen.
Yeah, and it's not just about that work. It's also about slotting in this unexpected, tech debt type work into an engineering team sprint that might already be full. So it may not be something that could be remedied right away, depending on your organization or kind of the projects that are going on. So it sounds like fairly simple, but there's a lot to unpack with pre-aggregation and what the impact is to your business.
Yeah, so this is a picture of Humble. This is the company that we spun out of, 5 years ago now. And this is actually a screenshot of the product we built there, which is essentially a SaaS application for sports media and entertainment companies to understand their audiences better. And what you can see on the screen here is comparing people who like the NFL to people who like the NBA. And you can see all these nice breakdowns of, here's, education level, here's household income, here's the age histogram, all this kind of really rich data populated on this page. And Humble allowed you to look at this stuff in real time and make changes in real time. You could say, I want people who like the NFL and Amazon.com, or something like that, and it would repopulate the page, within seconds, and you could get updates. So it's hard to understate what that kind of flow can do to your ability to understand your audience better, and I'm sure Erica can speak to it better than I can.
Yeah, I think just the scale of the data, and we've talked about this before, like this is likes data and this is Facebook likes, and it's this, you've described it better than me, but there's like a lot of people probably like the NFL or NBA, but it's really long tail out to these really like kind of not obvious things. So that the amount of data that you have here, the cardinality of it, like the endless possibilities for things that people like, can make this a very arduous process. So those efficiencies that we can bring to the table kind of spun out of the need for this segmentation process, an ability to visualize it very quickly and act on it.
Yeah, and so the reason I'm here is to talk about kind of the underlying technology that we originally developed at Humble. And at the time, we were just trying to solve the problems we had, which is like, oh, we just got this new client, they have 10 times more data than anybody else, and all our stuff is falling over. And what we ended up doing, which is typically not advisable, is building our own database. Which again, at the time, we didn't say that out loud. We were just like, oh, we'll just build this service, to handle these workloads. But after we sort of realized, like, wow, this thing really works, we kind of went back, and we spun out a company around it, and we said, like, how do we actually describe this thing in the market? Like, how does this fit into sort of the history of, databases, data storage, analytics? And what we landed on is, you start on the left here with row-oriented transactional databases. These have been around since at least the 70s, when the first sort of relational databases came out. And they store data the way you think about it in a spreadsheet, kind of row by row, which is great for transactional workloads where you're looking up a record, inserting a record, updating a record. Not so great if you want to do analytics. And analytics, in my informal definition, is asking questions about your entire data set. You want to ask questions that involve looking at large portions of your data, like what's the average age of all the people in my data set? And shifting over to the middle of this diagram, that's why columnar databases were invented to do a better job at analytics. And so it turns out if you arrange data not row by row, but you have all the data for a column stored together, you get a huge amount of efficiency gains when you're doing analytical queries. If you want to know average age, you just look at the data for age. And so your disk reads, your memory reads are confined to the data you actually care about. And so those reads, that IO is a huge source of performance loss in databases. So minimizing that is really crucial. Having like data all stored together, like, oh, a bunch of integers kind of in the same range, allows you to do interesting things with compression, which improves IO even more. So columnar was a huge benefit over row-oriented databases, to the tune of like 100x faster for analytical queries, and really, step function improvement for that type of workload. We think what we've done is essentially taken columnar to the next logical step, which is instead of breaking your data out column by column, you still do that, but you then break it out distinct value by distinct value within those columns. So if I have a column called hobbies, I might have a value called skiing. And I would make that sort of individually addressable. Like, I want to know how many people like skiing. I can go and just read the data about skiing. It's all contiguous on disk or in memory. And so I can go just grab that little piece and operate on it. And if I'm interested in a few of these different values, I can do that. And so this is all the benefits you got from going to columnar. You're sort of minimizing IO, but you get them again. And you also get the compression benefits again, because the way we store that data under the hood is all in compressed bitmaps. We store the string skiing once, and then we store a compressed bitmap that tells you, here are all the people who have who have that value skiing. And so it's basically like, what's the most compact way I can store, here's the subset of my global data set that has this value. And what we came up with was compressed bitmap. So under the hood, we have lots and lots of compressed bitmaps, and we've spent a lot of time optimizing code for storing, fetching, and computing on compressed bitmaps.
And you mentioned like at Humble, this spun out of the need because your systems were falling over. Can you like just quickly describe like kind of the scale of the systems that you were using that weren't holding up to what you needed to be done?
Yeah, at the time when we first rolled this out, I think we had a 20-some node Elasticsearch cluster that we basically just replaced with FeatureBase. Now, FeatureBase doesn't do free text search, so anything we were using, if we were any part of our workload that was free text search would still use Elasticsearch, but the majority of what we were doing was like group bys and top ends and really complex filters and stuff like that. And I don't want to be too down on Elasticsearch because this was like 2013, a long time ago. But we would have pages take 20-30 seconds to load, or Elasticsearch runs on the JVM and it would garbage collection would run and it would just not return results to queries. So it was really problematic when we start to get into the scale of hundreds of millions of consumers in the data store and tens of millions of Facebook pages, for example, that we were tracking.
And coming from like the analytics side of it, I can definitely attest to the fact that when you're sitting there waiting for something to load and churn through all of the data points, and even if you're just looking at a count group by, like sometimes it might take couple of minutes or even like 45 minutes for your query to come back. And if you've already kind of moved on to an email to answer that, then you might forget to come back to your query, and oh look, I forgot a comma, it didn't run. And so your day just becomes really fragmented, and all the context switching is really difficult to keep on task. So the benefits, when we're saying it, went from 20 seconds to a few milliseconds, like the if you add all of that time up over the course of a day or a week or a year, like you really start to see some cumulative benefits, and just like the mental work needed to keep going on a task is really improved. So
Yeah, I think that's something people really underestimate.
absolutely.
So I talked a little bit about the data format under the hood of FeatureBase on the previous slide. It turns out that when you store data in that way, it gives you some interesting capabilities kind of naturally. One of which is the ability to have multiple values for a particular column, for a particular record, rather than having, a person can have one hobby. You can really, in a really natural way, a person can have multiple hobbies. They can like multiple Facebook pages, and you can sort of track that within the column, within the table, without having to do what you would do in a relational database, which is have another table of hobbies and a many-to-many relation that joins them. So there's two things that happen here. There's sort of a reduction in the cognitive overhead of sort of like keeping the schema in your head, and there's also a huge performance gain to not needing to essentially do that join across tables. And so that's kind of what we're trying to represent with this image here, which, on the left, you have this sort of traditional hierarchical view of data. And then on the right side, we've got we've kind of zoomed in on the customer table, and it's, I'm going to call it a fat table because it has so much more information packed into it because of the ability to have these set fields in your table that can track multiple data points for a single column. So we'll show that a little bit more later on, but just kind of wanted to give that overview of the way you think about your data schema changes because of what the underlying data representation is good at.
And I definitely find, like, from an analytics perspective, on the right, having everything kind of centered around the entity or the customer that you're interested in really helps, especially people that haven't had experience with this type of hierarchical data model. A lot of mistakes are made in rolling this data up to represent more of what you see on the right hand side. And there's a reason that it's all split up into different tables in a relational database, and inevitably younger or less experienced analysts, they want to shove it all back together. Then it's not really usable. So there's a reason that it's stored like this, and kind of transitioning more to this centralized model, or the big fat table, is like what analysts really want, but the systems typically can't handle it. So with that, I think I'm going to hand it over to Jaffe to see a demo.
Yeah,
and if you think back, oh, go ahead.
Yeah, you go.
Okay, if you kind of think back to the picture that we had a couple of slides ago with the two different audiences and kind of comparing their performance, that might be, what we're going to show you today is kind of under the hood. But think about how this might power an application like that you might be using to either explore your data or to monitor the performance of some segmentation campaign on an outcome of interest, like conversion rates or lifetime value or something like that of your customers.
Yeah, so the marketing team has unwisely agreed to let me do a demo. This is not the flashy demo you'll get from our sales team. This is very much the function over form under the hood demo. So I'm sure, Erica, you'll help me let the audience use their imagination to think about what could be done with this kind of technology. But I will show you the nitty gritty of what kinds of things you have access to under the hood to build on top of. So these are kind of your primitives. What we've got here is I've actually got an ingest running over here. So this whole time we're going to have live data going into the system. But I've also run quite a bit of ingest beforehand so that we have some data to look at. So let's take a look at the data set. So this is a table of users. We have age, we have education level, gender, the income bracket, lifetime value I put in here. So you could imagine having, some model, machine learning model that you run separately that calculates an expected lifetime value of a particular customer. So that's something we have tracked in here, and political party, because why not? And I should say at this point, this is all generated data. So, there's possibly some ethical concerns with doing a webinar on real data. So this is all fake stuff, and which hopefully will lead to some fun hijinks later on. The other thing I have in here is domain. And so this is meant to simulate like a domain that, this person has visited, potentially at a particular time. So you can see that this is wrapped in square brackets because it is a set field, like we mentioned before. So you can have multiple values for a single record in this field. And there's really no limit on the number. I think, MySQL has set fields and you can have up to 64 things. You can have up to 64,000 things. You can have more than that. So these set fields are really flexible, and it's really natural for the underlying storage to represent things in this way. So let me turn on timing before I forget so we can kind of see what's going on. And let's just look at how big this data set is. So we do a count all. So there's 709 million records in this data set right now. And that count comes back in about 50 milliseconds. And just to prove that, yes, we are indeed ingesting data, there's now 711 million. So we've got, million records every few seconds coming in. What do we want to look at in this data, Erica?
Let's see. How about looking at the lifetime value by education level?
I love it. Amazingly, I had that query all ready to go. It's like we prepared for this or something. Yeah, so let's check it out. So broken down by education level, and we get the number of people who have that education level, and then we have the sum of the lifetime value. And so if you have the count and the sum, you could easily get the average. But just looking at this, it's like, oh, interesting. The highest sum is actually in the sum high school, and it's also the highest count. But let's just pretend that, like, for some reason, the highest lifetime value is in the some high school education level. Like, well, that's really interesting. Is our model broken? What's going on? What should we do next? What if we broke it down by gender as well?
All right, so.
Oh, I'm sorry. I was supposed to do gender and education level. Let's add that in. We didn't prepare that well. So actually I threw a filter on here. Oh no, sorry, that is what we wanted. So I filtered it down by just some high school and then broke it down by gender within that. And we can see, oh, it's the males that actually have the highest lifetime value. So they're kind of the outlier.
So I have to ask, what kind of super computer are you running all this on?
Right, yeah, I mean, with 700 million records and all these fields, you would think like some kind of cluster backing this, right? It's actually on my laptop, which, if that doesn't shock you, it should. I don't know of another technology that can do this. In fact, I know of a lot of technologies where you can run it on a lot more hardware and it takes a lot longer to answer these kinds of queries. So this is, and I mean, some of these are taking up to like half a second, which for us is like embarrassingly slow. But again, it's just running on my laptop. So you can really, I think the point I most want to drive home is efficiency. It's not just performance. It's like performance per watt, performance per dollar. Like you can do a lot more with a lot less. And that means you can push further to the right on that spectrum of less granular to more granular in your segmentation, and still have it be profitable. You know, going back to the definition of segmentation. So it's the efficiency is what's really important here.
And I'm thinking back to, you know, you said use your imagination on how you could actually use this. So thinking back to that dashboard that's comparing, you know, two segments. So if maybe you're, you know, you're part of the marketing team and you're trying to identify which set of, you know, who to really target for your marketing. And you're looking at audience A versus audience B. You can very quickly go in there and start to tweak audience A and audience B and iterate on the characteristics that are within that segment, or you know, that are making up that segment, to start really playing around with how to get that LTV up, or to get that conversion rate up. So the being able to iterate really quickly like this, and also on the data as it's coming in, so you're not having to wait on that pre-aggregation. You know, we're showing this data is just growing, and as soon as the data is available or generated, it's available to do computation on it. And that's not something that you would be able to do if you had that big red pre-aggregation step in the middle. You might have to wait until tomorrow or 3 days from now before you're able to get data that was just generated available.
Yeah, and in fact, let's do this. So you can see the set of fields we have here. I just did, you know, select star. Let's add a new one. Like we got a new data source. Let's add it in here. So I'm going to add in hobbies. So in addition to, you know, domains and gender and all this stuff, we're going to have a set field with hobbies in it. And there we can see it is added. Here's hobby. We got seashell collecting, you know, BMX, whittling. Why not? All kinds of good hobbies in here. And we can even do stuff like, I'm going off script, top K on the hobby field. And let me limit this to 10. What are the top hobbies? Lego building. Who knew? It's incredibly popular. What should we filter this on?
Let's see. So I like this set field and like showing the powerful, like how powerful that is. So if you remember the set field, it's like you can store multiple values within one field. But when you do this top K query, can you tell me, like, what is it actually pulling back? Like, I'm not seeing the combination, you know, like in a traditional database, if that was stored in one column, like you couldn't parse it out without doing some more processing on it.
Right. Yeah. So this is showing the number of people who individually like Lego building. Like it's one of the set of things that they like. It's not the only one necessarily. And to demonstrate that, I'll do a top K on hobbies and I'll filter it by a particular hobby. So this is going to filter down to only people who like cricket, but show us the other hobbies that they like. Right. And I mean, this is ridiculously fast. Like this was the problem that we built this technology to solve. And it's just absolutely insane that it can do this. But you know, you now see cricket at the top because we filtered by that. So literally everyone in the result set likes cricket. And then you see everything else that those same people like.
And this is really awesome to find those combinations that are really, like, there's combinations of things that are you're able to define your segment by, to really find where you're having the most impact. So this is, to be able to do this so quickly is just, quite frankly, it's mind blowing to me, which is why I'm here at Molecula.
If astute listeners might be wondering about like the cardinality of some of these things, and so for hobbies, for example, I think there's something like 600 hobbies. You know, it's not that much. We also put domains in here, and we can do like top K on domains. and get the top domains. You can see that took a little bit longer. We are also running 2 different ingests into this thing, and it's on my laptop. But there's a lot more domains, and I probably shouldn't do this, but there's 10,000 domains, and it just keeps going and going, and we can actually just say like, wait, just tell me how many there are to account distinct. So there's 10,000, and like I said, if you scale up the hardware a little bit, you can get into the tens of millions in cardinality and still have this be performant and still do these top queries and this kind of thing. So it's really, really powerful. And I mentioned bitmaps earlier, and again, those with a technical background will be wondering, bitmaps aren't typically used for higher cardinality stuff. With the latest advances in bitmap compression, they can go up into the tens of millions. You can do this and it works. So it's pretty cool stuff. And we have some other tricks for like storing integers and that kind of thing. You saw we were doing aggregates on like lifetime value, or you can do aggregates on age or whatever. So there's a lot going on under the hood here, but pretty interesting technology, I think, and has some interesting applications for customer segmentation and customer experience.
Yeah, and I know we could probably play around with this data all day and be happy, but in the if you are interested in seeing a demo that's more tailored to your environment or to the data that you have, please go to our website, click request a demo, and someone from our team will reach out and get that process going for you. We're really excited to show you today a little bit under the hood and some of the things that you can do to power your real-time applications. But we know that you have to have a little bit of an imagination to see this and how it would relate to your environment. So we're absolutely, always willing to have those conversations. I think we have a little bit of time left. I think we can get a couple of questions out. So I'm going to go to the question queue and see if we can get some questions answered. All right. So let's see. So here's one about scalability. So, we mentioned that you ran this on your laptop. Can you expand that to a multi-node system, or is it limited to your laptop?
No, yeah, you can absolutely expand it to multiple nodes. The underlying software is written in Go, so it can run on a variety of different architectures. It can take advantage of multi-core very well, and we originally developed it to run on clusters. So that's been in the bones from the start. 4 node, 7 node, 15 node. You can absolutely scale horizontally or vertically. Both work quite well.
And you kind of already touched on this, but I think since it was an actual question, maybe you just kind of reiterating what you said. This listener said, I've used a bitmap index in the past and it didn't work very well with high cardinality integers or floating data or keeping my data fresh. How is your product different? How is FeatureBase different?
Okay, yeah, so this is a really insightful question. I think we touched on some of the high cardinality stuff. If you look into like roaring bitmaps, that's sort of an open source thing that's come from academia about bitmap compression. Helps a lot on the cardinality side of things, but the freshness aspect, that has been a difficult engineering challenge to sort of be able to update these and keep everything sort of running. And there's a lot that goes on behind the scenes to sort of like apply updates in memory, save them to a write ahead log so they don't get lost, and then sort of flush them in the background. That's probably something we've spent more time on than anything else, is getting that such that you can be continuously updating your data, not just adding to it, but updating it, and still see fast queries and still have good freshness.
Awesome. And then I think we have time for one more. And if we don't get to your question today, please just know that we will follow up with you. So this person said, I noticed that you were using an unfamiliar language. My team uses SQL. would they have to learn a new coding language to use your product?
Yeah, so when we originally developed this, it was very bare bones, and we developed this language that we call Pequel to sort of map directly to the underlying data model, and so there's still a lot of that under there. You'll also saw I did use a little bit of SQL, and we support some amount of SQL just for convenience, but Pequel is really useful because it allows you to reason about the performance of what you're doing in a much more natural way once you understand the underlying data model. So you can get started with some SQL, if that's obviously what you're going to be more comfortable with. But it's definitely recommended when you get into this to start learning some Pequel to really be able to take advantage of the system and reason about the performance under the hood.
Awesome. Yeah, I think we've like in some customer work, we've reduced like pages and pages of SQL down to like a line or two of Pequel. So it's not like a huge cognitive lift to learn the Pequel, and you'll be happy that you did if you are using it.
Yeah, that's a really good point, and it's partially because the query language is designed to make some of these things easy, but it's also partially because of the simplification of the schema that we talked about, not having to have multiple tables, not having to do extra joins. It blows my mind, but we have seen that where it's like, oh, this SQL query is over a page long, and yeah, no, it's just like maybe 2 Pequel queries that are each one line or something.
All right. Well, thank you so much for joining us today, everyone. We really enjoyed talking to you about FeatureBase and how we can use it to optimize your architecture for customer segmentation or other clustering use cases. If you would like to learn more or speak to someone on our team about setting up a demo that is more tailored to your environment or your data or your use case, please go to our website, molecula.com, and request a demo.
Yeah, thanks so much and great questions.